Hello, my dear friends, and now we are going to learn about the final topic of digital logic design, which is the counters. Well, by its name, what you can predict that what is the meaning of counter? Can you think about this name? This name itself is giving us the hint that I count. So, what you can count? Well, numbers and states. So this is what counters do. It says I count the number or the states. That's all what it means. So counter is a device. Counter is a device which which stores or I can say display the number of times a a particular event event particular event or process can say or process has occurred. Hmm. And that with the relation with the with clock. So I'm not studying the definition so long. I just wrote whichever is just absolutely necessary to understand. That's the whole purpose. I'm not preparing you for any kind of the examination. Well, you can prepare for the examination on the point of the solid foundation that you are getting from here, but not in terms of writing the definition that you have to figure out through the notes that I am uploading. Well, counters is a device which store or display the particular event or process that has been working or being followed. So that's the whole purpose of the counters. So what it actually means? Well, the first one we have up counter. So in the up counter, we can also call it as which decrease the value, which decrease the value, decrease value. So there must be a down counter too. Well, sure, of course. So we have down counters which increase value. Well, can you figure out what I did? I just reversed two words. That's it. Well, if you have figured this out in the first look, that's what I wanted, my dear friend. It increases the value, it decreases the value. Well, we are sticking in the names with the logic. Down, decrease, up, increase. That's the whole point. Nothing special, nothing more logical than this state. Okay, so we can say that the counter is a device that counts the value from one state to another state. Counters come in two categories. Let me also present you with that. So, counters comes in two categories. First is called as asynchronous. Synchronous. Well, this is also called as ripple. So you can also call it as ripple counter. And this one is surely synchronous. Synchronous counter. Well, there is no special name for the synchronous counter, but we write the ripple because it ripples in the asynchronous counter. So these are the two types of the counters that how we count the things. So in asynchronous counter, if we look at this, it is a ripple counter The flip-flop output transition serves as a source for triggering the other flip-flop. So it triggers the other flip-flop. This is one flip-flop and it's going to trigger the other flip-flop. So that's the whole point of it. That's it. Let me present you with its diagram to understand it more clearly. And it's all about the clock, so we are activating our clock. So this is the clock, CLK, the most important thing. Now what we have, just make 1, 2, 3 and 4. Remember, we are studying a synchronous counter, or you can also say ripple counter. So this is ripple counter. So it is just going to count and display the result, and we are just studying it briefly so that we can understand that how it's working. So this is the part of the clock, and this is the J, and this is gonna be the K. So let's just connect everything first, then I will tell you that what's actually going on here. So this is what's going on, what's going on, what's going on here, all the places. And we have the J, and we have the K. Surely we have the output on my day. I'm making the circles also. I will let you know that why I am doing so. So these are the things that we just drawn, but also here we have J and K, J and K. So we do not need to make that complex diagram again and again of the JK flip-flops. Instead, we can make the IC presentation for it. So why we learned that much technical? Well, that to understand the logic. That's it. Nothing else. So once you understood it fully, just keep that idea in your mind, and whenever you have to make it, just make one box. Just like here we did. That's it. Well, let's set the values for it be 1 for all our cases. We want it 1 in all the cases. Okay, we want it all to be active because it's counting. That's what we are imagining it. And this will gonna be A1, this will gonna be A2, this will gonna be A3, and this will gonna be A4. Well, why I made this specific circle and specific points? Because this is what's transferring from one flip-flop to another flip-flop's clock input. That's the whole point here. Because what our counter has to do? It has to count. So you need to put a meter. Put a meter. Well, in this case we have this entire device here, but you have to put a meter in which you can write and study that what's the value. So that's the whole point of our synchronous or ripple counter. Well, I will add the picture of its timing diagram that you can study um, in the note section, and I will also try to put that here also so that you can see its timing diagram. Timing diagram means A1, A2, A3, A4 and the clock itself. So it will seem something like this, like the clock will seem like this, and this is clock, and these are the states A1, A2, A3 and A4. So these are the things that we are gonna see, but if I draw it like this you might get confused, so I'm going to add a neat and clean picture right over here so that you can see that how it's working, and on this state what is 0 and what is 1. That's the whole purpose of it. That's it. That's all it for a synchronous counter. Now we are on the final, the absolute final topic, which is our synchronous counter. So let's get encounter with our synchronous counter. Well, in the synchronous counter what we have, Well, it is not having any fancy name like ripple counter that ripples. Asynchronous counter is distinguished from ripple counter in that clock pulses are applied to the CP input for all flip-flops. Well, it is provided through different form. Well, what I mean with that, let me present you in the form of the diagram. Well, if you are going to be a master, well, of the subject that you are surely going to be, you are going to draw so many things again and again and again. So, if possible, get friendly with the thing because that's how we study everything. And that's actually enjoyable because when you understand what's written, you actually feel so good. So good. And we are almost done here. Okay, I need to make this for the clock pulses. So this is not the NOT gate. Don't underestimate the power of the JK. It is not using the NOT gate. Well, you can count it as NOT gate. That is okay. I will not mind with that. Okay, I will connect it in a while. For now, I am just making the wires out from here. And this will gonna give us the A1, A2, A3, and finally we have A4 here. And now we are almost on our final connections, but before that, the differentiating factor is coming. We are using 3 AND gates. Now the things are going to be changed forever. So let me add that up. So we are done adding these things. Okay, now we are just left for the final connections. So let's connect it. So this is connected and this is connected. Now this is connected and this is connected. And this is connected and this is also connected. So if you notice, my example of big ship was not wrong. Well, last time I said Titanic boat. Well, that was intentional. You may call that it's a big ship. Why you are calling it a boat? Because you are just replicating the same thing just for a larger thing. That's it. That's all it. So maybe if you have more functionalities, but that does not make it qualify to say something very complex thing it is. It's not that complex. You are an engineer. Let all the people say that it's complex. You just never say that anything is ever going to be complex. It's not going to complex, at least for you. It should not be the complex. Okay, with all that said, let's connect this one. Now you understood that why I added the AND gates to get the feedback. Yes, my dear friend, you got me right. So we have got our counter and surely the time is enabled here. I will also add the timing diagram right here, but let's just understand that what just happened. Well, in the JK, as you are seeing here, I'm just making a same kind of the diagram. But as you can see, in this case, each one is connected. Each clock, let me change the color so that you can see clearly. Each of this point is connected in series, right? And here it's dependent on the previous state. That's the whole change for the counter because this is independent. That's how we are calling it synchronized. Synchronized means every clock is showing one, so every clock will going to show one. That's the whole point. And in the asynchronous one, if it is showing 1, it has to process it, then it has to decide at 1 or 0, then it has to decide 1 or 0, then it has to decide 1 and 0. uh, Such a lengthy process, right? Now in this, everyone is clear: 1 1 1 1. That's it, that's the whole point. Like our brave soldiers, they know what they have to do, so they follow the same routine. Like you people are the engineers, digital logic design engineers. You know what you are studying, and even if something is not seemingly logical right now, will going to be useful and surely make its form of the logic in the real life. Yes, I skipped few things just because I want you to explore these all the things using your everyday computer habits. I call it computer habits. Like you store the program, you click the picture, you just save something, you delete something, your machine is working, sending, receiving all the time. So that's the whole point. Just relate it. Relate everything, because on the section of the logic, on the section of the design, on the section of the electronics, something is working on the background to make that happen in the simplest version. So simplest version is for the layman, and for these ones who can understand this, you, I, and us. Well, I meant that only an engineer or engineering mind can understand this. Only curiosity can take you to the next level. No one else, nothing else. Just the curiosity, the pure level of the curiosity. Like I gave you a dare to find that how synchronous and asynchronous counter actually work in our day-to-day life. Just try to figure this out, and this is the exciting ending for our counters. I just told you everything about the counters in the briefest way possible, because that's the whole idea. The whole idea is just about the counting, and something is synchronous, something is asynchronous, synchronous and asynchronous, that we just discussed. That's the whole point of the counters, and you have learned the counter, a device. I taught you the entire device in this much small time. It's just hardly been going to be 17 or 18 minutes. It's just precisely 18 minutes, and we learned everything about the counters. So congratulations, my dear friend. With this, we can wrap up this section, digital logic design, and in the next one, we are going to level up as the digital logic design engineer. Remember, if you get tired, have some relaxation, but never ever ever quit, because learning gives you the most exciting energy that nothing in the world can give you. And you came this far, I am sure you will go to the complete level and develop a complete understanding of the digital logic and engineering, design, engineering, and electronics thing. So, with all that said, and the good blessings, take care, God bless, and we see ourselves in the next section. Till that time, take some refreshments and see you in the next one. Sayonara.